Good morning. Welcome to section 7.6 and 9.6 notes, day one. In this section, we're going to be looking at transformations where we take an initial shape, we multiply it by a scale factor and either enlarge it or reduce it. All right. So we're going to first start by determining a scale factor, which means what do we have to multiply that initial shape by to get the second one? This is called a dilation. Okay, a dilation takes a figure, makes it bigger or smaller. Okay, then we're going to do some transformations or some dilations with a given scale factor. Okay, so in this first part, we're going to start with determining whether the transformation is an enlargement or reduction. This is the easy part. Okay, look at number one. Starts with A. A is smaller than B, right? The black one. The black parallelogram is smaller than B, the gray one. That means it's an enlargement because it's getting bigger. Okay, we start with black one, we get bigger, it's an enlargement. Now, to find that scale factor, what we need to do is find the length of two corresponding sides. To do this, we can find distance formula, or we can use distance formula. Remember, distance formula equals the square root of x2. We take the 2 points, we subtract them, squared plus y2 minus y1 squared. Now, that's a lot of work, and that will work for any side. But if you guys notice, look at all these figures, and they all have sides that are either horizontal or vertical. If we have sides that are horizontal or vertical, we don't need to use distance formula because we can simply count. Look at this side right there, 2 units, 1, 2. Look at this side right there, boom, 1, 2, 3, 4 units. So to figure out our scale factor, we're just saying, what do we have to multiply 2 by to get it to be 4? And that's pretty obvious, right? Okay, so remember, we did a scale factor previously by taking the side over its corresponding side. 4 divided by 2 is 2. And we know that we want that scale factor to be bigger than 1 because it's an enlargement. Okay, if I put 2 over 4, that would be smaller than 1. That would give me a reduction. So I know I have to do 4 over 2 to get that scale factor. All right, again, look at number 2. I could use distance formula if I wanted to find the length of this side. Sure, that'd be great. But it's much easier for me to use this vertical one because all I have to do is count. 1, 2, 3, 4, 5, 6 units. And then we have inside that a smaller triangle. And again, I can just count that. 1, 2, 3 units. So now we're looking at the bigger shape, the black one, A, is getting smaller. That's a reduction. So now the scale factor has to be less than 1. So when I take 3, we call that the image, the second one, over 6, there's our scale factor is 1/2. Because 6 times 1/2 equals 3. All right? I hope you guys don't mind that I'm not practicing distance formula, but we don't need to use it here. Look, again, here's a horizontal side length. I'm going to use this one. 1, 2, 3. That's what I'm starting with. Now look, this is getting bigger. 1, 2, 3, 4, 5, 6 again. This is an enlargement because I'm getting smaller to bigger. That means my scale factor is going to be bigger. So I put the larger one on top. 6 divided by 3 gives me a scale factor of 2. Okay, much easier than using distance formula. Okay. Verification. Use distance formula. But we don't have to because we can use the graph and count, okay? So we can always use distance formula, but we don't have to in this case. All right, let's look at our next several here. Determine whether the transformation from A to B is a enlargement or reduction. Same exact thing. Look at A. It's way bigger than B. That means it's a reduction. Okay. Now, again, I could use any side I want, but check it out. I have a horizontal side. I don't need to use distance formula. I can count. 1, 2, 3, 4, 5, 6 units. Go to my small one. 1, 2, 3. There's my corresponding side. It's a reduction. It's getting smaller, so that means we take the small side over the big side, and our scale factor is 1/2. All right, hopefully we're seeing this pattern. Large, going smaller, reduction. Again, horizontal side. Let's use this one. 1, 2, 3, 4, 5. Come on, pen. Go to my other one. Now I got a half here. 2.5. There it is. 2.5. It's a reduction, so it's 5 over 2.5. That would be 2. Actually, so we reverse that one. We don't want 5 over 2.5 because we're getting smaller, right? So we got to do 2.5 over 5. And that, you can see, is going to be 1/2 again. All right, now, again, we see large getting smaller. There's a reduction. Now, all these sides are diagonal, so I can use distance formula. The other thing I can use is I can use the diagonals of this figure. Remember, our corresponding parts are proportional too. So if you do the diagonals, I can see the same ratio. 1, 2, 3, 4, 5, 6, 7, 8. And this diagonal, 1, 2, 3, 4. I don't know about you guys, but when I can make life easier myself, make these problems easy, I'm going to do it. We know this is a reduction, so again, smaller piece over, and there's our scale factor is 1/2. Okay. Now again, if you need to, use distance formula to find the length of corresponding sides. All right. In the next part here, now we're going to sketch the triangles and sketch a dilation, okay, by scale factor 1/2. So let's plot these points first. So we have A is -4, 2, and label our points. B is 3, 6, write 3, -4, 2. All right, so there's our triangle ABC. Plot those points. Please use your straight edge. Sorry, it's very difficult for me to get a straight line on the computer with the stylus here. So now what we're going to do to use that scale factor is we're going to simply multiply that times each of our points. So point A was -4, 2. We're going to call our new point A prime, and all we have to do is multiply that times 1/2. So it's that easy. 1/2 times -4 is -2, and 1/2 times 2 is 1. -2, 1. Okay. We know that the scale factor is 1/2, so that means it's going to be getting smaller. There's A prime. Now we'll take B. 1/2 times 3, 6 gives us B prime. 1/2 times 3 is 1.5, and 1/2 times 6 is 3. So 1.5, we're just going to go right in between 1 and 2. Well, not draw there. 1, 2, 3. Put our point. Okay. And then C prime. 1/2 times 0 is 0. 1/2 times -4 is -2. And there's our new point. 1.5, 3 disappeared on us. And there's our new triangle. Pretty easy, right? Okay, let's do the next one. Alright. Okay, now we have a scale factor 2. That's bigger than 1, so we know we're doubling it. It's going to be an enlargement. So let's plot our triangle PQR. -1, 4. -4, 2. P, Q, and R, -1, -3. Okay. There's our triangle. And for some reason, I don't know why these points keep disappearing on me. Okay, there's our triangle. Now, again, all we do is we take that scale factor, we multiply times each point. 2 times -1, 4. -2, 8. 2 times -4, 2. -8, 4. And 2 times -1, -3 is -2, -6. So let's see what it looks like. Now remember, the shape should still be the same, but we're doubling the size. -2, 8. -8, comma 4, -2, comma -6. Okay, notice size is doubled. The shape is the same. That's P prime, that's Q prime, and that's R prime. All right, now we have a scale factor of 3 over 2. Not a big deal. Let's sketch our triangle. But 3 over 2 is bigger than 1. That means it's going to get bigger. It's going to be an enlargement. Okay, there's A. B is 6, comma 4. C is 4, comma -2. Again, please use your straight edge so you get a nice triangle there. All right, now our scale factor is 3 over 2. If you want to keep it as that, that's fine, but 3 over 2 is a nice decimal, it's 1.5. So I'm just going to use 1.5. 1.5 times -2, comma 0 equals -3, comma 0. 1.5 times 6, comma 4 equals 9, comma 6. 1.5 times 4, comma -2 equals 6, comma -3. All right. Again, the shape should be the same, the orientation should be the same, but the size is going to be bigger. -3, comma 0. There's A prime. 9, comma 6. It's going to be all the way up here. There's B prime. And 6, comma -3. Right there. There's C prime. And we can see it's right above it here. Right below it here. Okay? Same size. Or sorry, same shape, different size. And that's it for dilations today. Our next lesson, we're going to talk about changing the center of the dilation and also finding the coordinates. Nice work. Thank you guys very much. Have a great day.